Hello, hello, and welcome to part 9 of the Mac SC30 Reloaded logic board build. Um, this is the board, and since part 8, um, I've been doing some cleanup and troubleshooting. We ended part 8 at a state where the computer the computer didn't do anything when it was powered. It just went straight to a black screen. There was no chime, no sign of any logic working. Um, so that was a bummer, of course. At the end of that episode, we soldered the missing ferrite bead at that time, ferrite beads. Um, and today, or actually since then, I spent about a week fixing up solder joints and uh, making things nicer, and got it to a little bit of a better state than it was before. So here I'd like to give you all a recap of what I did since last time. Um, and for this episode onwards, I also have a little bit of an improvement. I have installed a little uh, arm for the one of the webcams here, so that I can show in better detail what's going on the board. I think this is going to be better for showing off what goes on um, with larger components as compared to the microscope. Although this webcam seems to be struggling a little bit with focus, which is annoying. So let's see if we can think this. Oops. That's weird. I don't know why it doesn't want to stay. Oh, maybe I need to put it. Huh. That was a bummer. It worked for a good long while. I don't know why it doesn't want to stay on its axis here. It just slumps down. What the? Did this thing already break? Jeez. What is this thing? Maybe we need to do it like so? No. Okay. Yeah, I think it's stable again now. That was frustrating. So yeah, this... okay, there we go. Yeah, this little camera arm is not the best. It was cheap. There we go. So the idea is that this view should allow us to give us a little bit of a macro view of the components as opposed to the microscope. But I have both lined up if needed. So yeah, I think this is pretty good. So what I did since last time, um, I did solder on the two last components that were salvaged from the donor board. We have this L1 here, which is a filter. So if you look at the fact sheets, L1 is the filter for the ADB bus, which is apparently consists of 4 inductors in this package here, this 8-pin package. Um, so it's a simple 8-pin through hole soldering job there. Turned out pretty nicely. So yeah, this is for the ADB bus. I don't think it's mandatory for the chime test, but I thought it was good to have that on there. Instead of floating around. And then it's this one, which is also an inductor, I believe. This L2. Let's find L2 on the sheet. L2, yeah, it's down here. So yeah, this is the audio filter, which is, yeah, it's a coil. It's a very simple component. But I think when I was looking at the traces that were going here, heading towards the headphone port, headphone jack. I think that this filter is part of the circuitry of this headphone jack. And without it, we probably won't get anything out of here. So the chime test was actually not, it was not a valid chime test at all. So I think we need, so it says in the sheet that we either need to jumper this. Oh yeah, hi Xenocide 21. Thanks for joining. Um, so I'm just covering what I've done since last time. Um, so I've soldered this filter that should now actually make the headphone jack work. And I've tested that as far as I can hear the crackle in the speakers when you turn on the computer so that the amplifier circuitry kicks off. Um, so yeah, those two components are on here. It's in good shape, I think. And so I think before anything else, let me then demonstrate what happens now. I think I should show off what the computer actually looks like now. What happens when I hook this up. So let's see here. I think for this I can, how much does this turn? I can do it like so. There we go. So I'll just hook this up to the computer again, and then we can probably, let's see here. If I can find the power cord, wherever. Where did my power cord go? Ah, there it is. It's the power cord. Oh, too many cords. Tangled. Not good. There we go. So let's so of course always word of warning when you work with CRTs. This is an exposed CRT. We have about 10K of volts. So going around once this thing is powered, so it's good to be careful. Also, we have a power supply exposed there. Here we go. So we have the logic port floating around back there. We have the powers hooked up. I think everything is connected. So let's see what happens. So the computer turns on, and we get this screen. Right. This is close up. This is the current state. So more knowledgeable people than I have told me that this is just the default state of the video ROM. So it's just memory garbage on screen, and the ROM is supposed to be executed by the ROM code should be executed by the CPU, and it should clear the video RAM, but it's not. So this is what we get. But at least the system clock is working, the logic is active somehow. But the CPU is not really executing code. So that's the state we start at today. All right. Let's flip this around again. Whoops. Carefully get the logic board out of it. Here we go. Oh, sorry, I should have switched over to this view when I did that. Sorry about that. I hope that it was still visible what's going on screen there. One quick thing I wanted to show off before I start. So this is actually a video that I took. So when I was testing out this this new setup with the camera arm, I was just shooting some test footage. So this is some of the work. This is some of the work that I did on this board leading up to the video ROM actually showing up on screen, right? The logic actually working. So what I did was I went through all of the SOIC chips, all these little ICs with like flayed legs like that, and put flux, that lesson learned, use more flux basically. I put flux on everything, reflowed all the joints, make sure that they were not cold, that they had good contact. I think in particular the edge pins on some of these chips were a little bit iffy. Um, so this was a valuable thing to do. So yeah, lesson learned, use more flux, be more mindful with these SOIC chips. So yeah, Xenocide, you say, what if the CPU isn't making good contact on all of its pins due to the machine socket? Well, it is a possibility. Well, one of the things that I actually did over the last week was that I took the CPU out of the socket, and I went over all of the pins on the socket on the CPU with uh, the soldering iron and some wick to really get all of the scrap, the leftover solder off of them, so that we had all of the pins were nice and clean. And then I put it back in again with some contact cleaner. So I'm pretty confident, and I also went over the pins, the through-hole pins on the bottom, and reflowed some of the joints there. So I'm pretty confident that the CPU should have good contact. But it's always a possibility that something is not right with the CPU. But we'll see. Yeah, so it looks much better now. I should probably have filmed that. So regardless of what you thought, Xenocide, it was actually pretty easy to get the CPU out of the socket again. I just used one of my little angled picks to pry it out of there very carefully. So it came out really nicely, and it cleaned up really well. But there's always the off chance that one of these large chips has some damage to them because of battery explosions or uh, cap leakage. So we'll see. So yeah, anyway, this video is demonstrating how I carefully redid all of the joints here on these chips. Yeah, it's funny. It looked super stubborn. Like but I think on the flip side, just the fact that it didn't, because of the scrap solder on some of the pins, it just didn't go in that well. So it's fairly easy to get out again. So of course now this rework here is definitely made more complicated by the fact that we have these large ICs and sockets surrounding them now. So it would have been nice to have done this ahead of time rather than now. But lessons learned. There's a bridge, still a bridge. Let's get rid of that bridge. That looks better. Oh, and then another thing that I did, so talking about this I asked around on the Tinker Different Discord, and I got a lead on a 68K MLA thread where somebody who was fixing their SE30 found out that some of the original resistor packs, like these RP456 you see on the top of the video here, they had gone bad, like the resistor packs themselves. Oh, here we go. Here I'm looking at this specific one. This RP1 here had gone bad on this one person's SE30, so that it was shorted between a few of the legs, or it had only maybe a couple of hundred ohms of resistance where they're actually supposed to be not connected. So another thing I did was I went over all of the resistor packs and tested that they were, as specified, that they were either isolated or that, all of the bust pins were connected correctly to the input pin. So the only one weird thing I found as I was doing that was on resistor pack 5. Um, there was some, there wasn't shorts, but between a few of the pins, there was something like 5 to 10 mega ohms um, of resistance, which was a bit weird. So um, look at this one, this RP5 here. This one was a little bit weird, or is a little bit weird in that a few of the pins in between are actually, if you test, for instance, pin 15 and pin 3 there, which are not supposed to be connected, you get something like 8 mega ohms of resistance. And I don't know if that's because of the rest of the circuitry here um, introduces that kind of resistance. Yeah, that's a problem. I realized that only recently, and I don't think I have any. I think these are isolated 22 ohm resistor packs, and I don't have any of those either. So I'd have to go again and order more of these. And this is something I should probably ask somebody on the forums or somewhere on the Discord if they can actually test on their working SE30 to see if that's expected if I remove it. Yeah, maybe. We can try that. We can play around with RP5 and see if that makes a difference. But yeah, that was the one iffy one. But honestly, I mean, something like 5, 6, 7, 12 mega ohms of resistance. I mean, that's almost the same as not connected, isn't it? As far as this kind of low voltage circuitry goes. But I don't know. Maybe I'm not an expert, so but it feels like that. Um, but anyway, it's a lead if we need. Um, so otherwise, I think that's all I did with this board since last time. Um, So I think we're gonna go and open up the package from DigiKey. DigiKey, always helpful, except this time it was stuck in transit for a good week. I think because there was bad weather um, in, the, in North Dakota specifically. um, with it off the board, it'll have no interference with other traces on the board. So if it still does it with it off, it means the chip is not, it's chipped in, not the board. But what if there is So, I mean, if you have passive components with resistance that are connected in the circuit somewhere else, you can still get that kind of interference, right, between two test points that are not supposed to be connected, but they're actually connected through some other means. No? There we go. Uh, resistor array, 15 resistors in a 1K with 1K ohms. So yeah, so this is a um, bust resistor pack, which is exactly what we need. I also, let's see here, I bought some desoldering braid because it's good to have. And these are some caps for a friend who needed them. I'll put that on the side. And I also ordered these fuses. So these are 63 volt AC, DC, SMD. So these are replacement fuses for the really fragile ones that we messed around with before, like these guys. I don't trust these. I think they we either use too much heat or they're just, I don't know, deteriorating somehow. Oh, you're saying that, oh yeah, we should, okay, I see what you're saying. We should take the chip off the board and test it. Yeah, that's a good idea, of course. That is a good point. So that's it for the DG key package. So yeah, I was thinking we should also replace these fuses just to be sure that they are not causing bad behavior. There are the resistor packs. All right. So let's start with uh, the main act. So we need to remove this RP, not RP5 down here. RP8. There it is. Let's. All right, turning on my vapor. Yeah, let's hope that it makes a difference. Yeah, I did get we got another lead from a person who had been for Android actually who had been repairing his brother's SC30. That was no, actually that was no, that was a different one. Yeah, he had um, a similar issue, and there were some suggestions that these SOIC chips here are just prone to failure, or they're prone to get um, cold solder joints. Okay, let's turn on the vapor fan thing. Here's my cheap rework station. Actually, before we do, let's double check the fact sheet to make sure we install the resistor pack in the right spot. So we're looking, see here, RP8. There we go. So RP8 is supposed to be a 1K ohm resistor pack, resistor network, 15 resistors. So yeah, this is the correct one, RP8. Why didn't I put a socket for the 6888 too? Yeah, uh, are there actually, I don't know if, are there surface mounts, um, what are they called again? Are there surface mounts sockets for these PLCC chips? Aren't they, don't you have to have like, so for instance, these are spaces for PLCC sockets, and they are through hole, right? So you get through hole socket for this, and then you can insert a PLCC chip like this. Whereas what we have on the board here is just, these are just surface mount pads. Oh, they do? They have sockets? Yeah. I guess I just didn't think about that or know about that. It's also very little clearance with the sim sockets here. It's just a tightly packed board. But I have seen folks who have used sockets for this. Maybe for... I have more of these boards, so maybe I can make another build. Anyway, we should remove... Without further ado, let's remove RP8. So hot air, let's bring it down to 350 degrees Celsius. I should probably bring my tweezers. Okay, let's apply some heat to RP8. Yeah. I mean, it could be doable, but yeah, it's... Yeah, so it's funny, this is the third time lucky with this resistor pack. There we go, it's off. All right. Bring out the soldering iron. Okay, thanks. Yeah, you can check it out. There are some sockets. All right. So let's first of all we should clean up the pads. Okay, it's nice and clean tip. All right. I need alcohol. Here's my alcohol drip bottle. And some brand new resistor packs. Beautiful. Let's get one of these here, like so. And the little dot is on the side there, so we should align it with the notch on the board right there. Notch, dot. And I will trust that a brand new part is testing correctly, so I'm not going to test this before we put it in. But I will definitely make it a point to be more diligent about testing certain components before installing them. I think that's a good habit to have when dealing with old components like this. Here's the flux. Yay. Actually, I did get some new flux today. I did get some of this. The package looks pretty much exactly the same as the solder paste I was using before. It's the same MG Chemicals from Canada. But this is no clean flux paste. So let's try using that today. So it's a syringe setup here again. So to get that out of that little container, and then we have all the parts here. Here's the paste itself. 8341 no clean flux pastes by MG Chemicals. It's ROHS compliant. It's good. It's not quite as toxic as the solder paste, it seems. And here's the syringe needle with a nice little plastic what's it called? Lid? No, lid. Yeah, anyway. Tip. Let's get the top off there, and then we put it in. Put in the syringe needle, and we spin it around, screw it on. Take off at the other side. Cap, that's right, cap. See if we can fit this. What is that? Plunger? Doesn't want to go in. Oh, maybe. Yeah, there's quite a lot of flux in this one. But I think for the first two Yeah, whatever. Let's put flux across all of them. I'm gonna get a paper tissue just so we can wipe stuff off on. Paper tissue. Whoops. So let's see if we can get some flux out of this. Oh, there's some flux. Look at that. Oops, whoops. I'm making a mess. Oh, this is pretty thick flux. Here we go. Words are very hard, yes. All right, so we'll put our syringe to the side there. So I never used this kind of solder paste before, so I don't know really what to expect. I think this is not, sorry, not solder paste, flux. So I think we still need to add solder to this, right? Yeah, I'm not sure if this is a good way to do this. It's hard to see if it's aligned well. Yeah, it's no clean until you make a mess. Yeah, it's funny how no clean are the fluxes that leaves the most crappy looking residue around, but you know it's no clean because the residue it leaves behind is harmless, right? Doesn't It's not conductive, it's not corrosive, or it's not very corrosive. So you can potentially get away with not cleaning it up. Um, but it's still it's a good habit to clean up, I think. Let's bring temperature down to 350. I don't, no idea what to expect here. Jeez. Yeah, so it looks like that one solder joint there is all right. So we probably want to do the one on the other side, the opposite, diametrically opposite side, like so. I think that gives us uh, two nice joints there, and I should probably bring out the loop, little LED powered loop. This is very handy. I use that all the time. Let me check the joints. Yeah, so those two joints look beautiful. So hopefully that'll give us just a cakewalk to drag solder the rest of these joints. Okay, this is a little bit cumbersome. Oops. Look at that massive bridge. If the camera can focus. Come on, focus. Doesn't want to focus. But yeah, there's a big bridge there. Okay, bridge is gone. Let's do the other side. So I think there's a little bridge that I need to clear up right here. There we go. Okay. Bridge is gone. I think that looks pretty nice. I'm gonna double check the joints with my loop. Yes, those look good. The other side, 4 of these look a little bit weak, a little bit thin. I'm gonna add some more solder to the ones over here. Like so. All right. Maybe I should angle this camera down a little bit. Like so, maybe. You can see my tools a little bit better. Yeah, I love this. This flux is really nice. I like. Um, it gives you a really. I mean, it stays in place for starters. Yeah, cool. Yeah, thanks. I'm glad you like the list. I'll definitely add this solder paste to that list. Oh, sorry, flux paste. Come on, focus. Anyway, I should still use my toothbrush to clean a little bit with alcohol, I think. It's always good to do. Well, so what do you think, Sensei? Shall we try it? Shall we try this thing now? Uh, yeah, I don't know. I think this camera is just... It's not great for close-up shots. Actually, there's some more residue here I need to clean up. Okay, I think that should do it. So let's see what happens now. I don't see anything obviously wrong. So let's try this. Just put this back in the computer here. I'm gonna turn the computer around again. Turn off the fan. Put these things to the side. So, yeah, we'll see. I don't really have. I'm not holding out hope, to be honest. And by the way, there's no ROM, no RAM in this one right now. But at least we should start with a smoke test and see what happens when we don't have anything in it. So everything is on here. Let's turn it on. So for starters, we get nothing, right? So I think the ROM is supposed to be able to clear this out, right? If the ROM is running. So we need to put the ROM in. So let's put the ROM in first. Turn this off again. Take this out. So let's put the ROM in place. Like so. And let's put the nice 16 megabyte sticks in here again. I haven't actually tested these 16 meg sticks in another computer, but at least it should give us something, right? So it's hooked up again. Let's turn it on. Yes, unfortunately, we still have the um, same symptoms. So the ROM computer is clearly not executing the ROM, right? And you're right. It could be that CPU it doesn't have good contact on a couple of pins. Um, but we should definitely test out that one resistor pack that we were suspicious of. So anyway, let's power cycle this thing just one more time. So yeah, nothing. Yeah, so let's take that resistor pack that we're suspicious of out of this machine and then see if we see that same um, resistance where there should be no connection. That's a good test. Okay, let's take this bad boy out. Let's spin this back on here. So I think, yeah, we need to take the RAM out again because I don't think we should play with hot air around here when the RAM is hanging around. Come on, get out. Okay, take out the ROM first. It's I can't get to one of the clips well. There we go. Okay, take the RAM sticks out. So this resistor pack here is what I'm suspicious of, and let's see if I can demonstrate what happens. See what the best way to do this is. It's always hard to show off what's happening on a multimeter. Maybe I can put. No, it's not gonna be. uh, it's a little bit of a mess. See if this works. So if I test, let's see here, these two pins. Let's see here. There's a 22 ohm resistance, 23, something like that. And then we have. So yeah, these are isolated. So if I go these two pins, so 1 and 16, that's a good resistance. If I go 1 and 15, there is no connection, right? This is correct, overload. If I do 2 and 15, uh, sorry, I think I don't have great connection there. There we go, 22 ohms again. And then we go 3 and 15, there's overload. And then we have 22 again here on 4 and 4. What is this? Is this 1, 2, 3, 4, 5, 6, 7? Yeah, it's 8. So 16, 15, 16, 15, 14, 13, right? So on 13 and 4, we still have that 22 ohm resistance. And then 12, interesting. So maybe that weird resistance is gone, or maybe that was a different resistor pack. Let me quickly test off camera just so that I can see if I can just track down what I was seeing. So let's see here, these two, but these two, nope. Two, nothing. It's weird. I just can't see that again. And it was very consistent a few days ago. So I wonder if when I added this resistor pack with the correct values, that resistance went away. 22, yeah, these are all good. 22, nothing. 22, nothing. 22, nothing. Okay, never mind. So those resistor packs are probably good then. So I don't think it will matter much, but we should definitely install the new fuses as well while we're at it, just so that we eliminate any factor. I don't think these fuses should have any such large impact on anything. But let's at least take care of that. Yeah, it's interesting. It must have been that resistor pack with the wrong value in that spot caused some errant resistance between those pins on RP5 that are now gone. We should test that hypothesis by installing the incorrect one again, but maybe not today. So for now, let's just get rid of these very fragile fuses. Oops, look at that, it just fell apart. These are so fragile. So maybe somebody watching can tell us how you work with these fuses without destroying them. Maybe they are like one-use components. You install them once and you're supposed to never touch them again. Oh, look at that. Okay. All right. Let's put this away again. Let's get the soldering iron back up. Let's get rid of this. You just put a solder. Yeah, you don't have a fuse at all. We can take that, right? We can just take the excess voltage to the gut. Things will be fine. I think some solder mask has come off. That's funny. Right there, there's some solder mask that's come off, I think. Because we've been back and forth flailing around with these fuses a couple of times. Yeah, who would ever use like a faulty floppy drive or something with a SC30 or a faulty ADB device? So let's just clean this up just a little bit. Yeah, they all blew. All the fuses are dead. Oops, sorry. All right, let's get 3 new fuses on there. If we can get this open, take the film off. There we go. 3 fuses. Yeah, these looks a little bit more like regular SMD packages. I don't think these are polarized. Well, how would a fuse be polarized? I'm not sure. Let's get some tools out of the way. And I don't think I'll use extra flux for this. It should be easy enough to get heat onto those pads. Should be easy enough. Famous last words. Let's do the usual of tinning 1 pad each, and then we grab these fuses. So let's yeah, I'm just looking at it with the loop. I don't see any polarity markings, so they should be good. Oops. Okay, this is not going too well. Maybe I need flux after all. I just need to make sure that there's enough pad on the other side. I think these pads are pretty small, pretty tight. It's hard to fit these components on here. Here we go. Really? You want flux? Fine. Let's use some of this liquid flux. Okay. Let's check the joint with the loop. These are really easy to test once they're in the board. You can just test for continuity over the neighboring pads. There. Let's see. These pads are so tight. Yeah, I don't have enough pad on that side, on the other side. I need to slide this a little further. like so. Then we'll see if we can get the other side on there. There's some flux. Okay, so at least we have a bunch of solder on those pads. So let's test for continuity. Let's put the um, multimeter into, there we go, beeping continuity mode. And let's test this via to this via. Okay, got the beep there. That's good. Test this via to this via. Yeah, that's continuity. Here and here. All right, so we have continuity across the board. That's good. So yeah, let's do a final test, and then I'll probably have to wrap up for today. Um, but at least we should have all the right value components on this board now, so that's an improvement. Um, so let's put tools away, spin the monitor over here. Let's hook it up to the computer. There we go. It's kind of floating around back. Oh, actually should. Let's at least let's put the ROM in there, because we should at least get a blank screen, I think. Probably don't need RAM for the test right now. You want RAM in too? Okay, fine, I'll put RAM in there. Fine. But I mean, even without RAM, we should be getting like a gray screen, right? The CPU should execute the ROM code, which should blank the screen, which is what we're not getting right now. There we go. It's on. Press the button. And grayness. So yeah, still video RAM garbage on there. So this is a non-functioning SE30, unfortunately. I did get, so the one other lead that I got from asking on the Discord was that the power supply might be giving just a tad bit incorrect voltage. We had like 12.7 volts on the 12 volt rails and 11.2 or 3 or something on the minus 12 volt rail. I don't think that should affect the like the 5 volt circuitry, but you never know. Um, yeah, the God of Max, yeah. Um, I don't think the gods can help us here. I think we are up. Oh, sorry, I keep forgetting I should switch over to this view. Um, yeah, unfortunately, these Apple IIs and Macs here are not helping out. They're not doing anything right now. So the power supply could be a thing. I don't think that should be the thing, but it's something we can at least play around with. Um, beyond that, I'm a little bit at a loss. I mean, it could be some of the other SOIC chips that are bad. There could still be some bad cold solder joints um, around sort of the clock chip, the oscillator, and what are they called? It's jerks. Yeah, they need to help out. Poor SE30 here, not getting any help. Um, but yeah, the quest continues to try and resurrect this Left 4 Dead Macintosh SE30. Um, it's a bummer. Let's power cycle it one more time. I don't think it'll make a difference, but By the way, the garbage here is slightly different every time. I think it's just, the state of the video RAM at the time you turn it on. Um, one thing we should test if, I don't think it will be, but we should at least, let me see if I get a chime out of this. I'm just gonna cheat and use these headphones, or um, I don't want to set up the speakers right now, the powered speakers. Yeah, so still no chime, but you can hear the amplifier crackle. You get like the crackle when the computer turns on. So yeah, let's wrap it up there. Thanks for watching again. I'll keep working on this. I'll track down more leads, and I think next time I'll probably bust out my oscilloscope. Let's see here. Uh, it sits over here. I have this portable Handtech oscilloscope that may not be sensitive enough to really get like this is a 16 megahertz machine, and I don't know, should probably be okay. But I'll see if we can um, track down a few signals and see uh, why the ROM isn't getting executed. At least it can give us some hints about what's going on. So yeah, that's it for today. Thanks for watching, and have a great rest of your day. Bye bye.